Hey everybody, and welcome back to our series covering Singularity Container Services. In case you've missed the previous videos, so far in the series we have done things like covering workflow readiness, creating an account, and an authentication token. In this video, we will pick up where we left off in the previous and sign the container that we created. So be sure to go back and watch that previous video if you haven't already. Before we pull the TensorFlow container, let's touch on signing and what exactly that means. Starting in the Singularity 3.0 versions, the ability to create and manage PGP keys to sign and verify containers was introduced. This gives Singularity users a trusted method to share containers while ensuring bit-for-bit reproduction of the original container. Since we did not sign the container that we made in the previous video, let's get ready to do that now. Before we can sign our container, however, we need to generate one or more keys with the Singularity CLI, which can be pushed to the Singularity Container Services key store. These keys should be managed as if they were a password and not shared with anybody else. We recommend using your favorite password manager to keep your keys safe and secure, but you could proceed with whichever process works best for your workflow. Using the email associated with your Singularity Container Services account, you can create a new key pair. Enter in your account details, add a comment and a passphrase, and have the Singularity CLI push it to the key store. Now that we have that created, we can use the command line and web interface to display the keys. Using the Singularity key list command should give you a similar output as you see here. The key is 0, and the letters shown stand for the following. U stands for user, C is the creation date and time, F is fingerprint, and L is for key length. Now that we have our key, let's move back to the Singularity Container Services dashboard. If you select My Keys, you should be able to see the key we just created along with the key name, description, creation date, algorithm, bits used, and the fingerprint. We also have a few examples of container signing and image verification commands. Since Singularity Container Services does not store your private key information, containers must be signed by the local Singularity client. So, we will have to retrieve our container from the Singularity Container Services library, and we have two ways to do that. One, being to pull the container from the library using the Singularity Client pull command, or 2, download the container from the Singularity Container Services web interface. For this demonstration, we are going to use the command line. Note, when pulling a container with a tag, you may notice the semicolon is converted to an underscore in the file name. When you sign a container for the first time, Singularity will generate a PGP signing key pair and optionally upload the public key to the key store. There, it will be available for container verification requests. After you enter your passphrase key, you should see that your container has been signed. If you are looking for more information on advanced signing capabilities, check the link in the description for documentation on CIF IDs and groups. Next, we'll use the Singularity CIF list command to see the details of the container that we just signed. After that, we'll use the CIF verification functionality to ensure the container has not been modified. If another user tried to run this same verification against an image in the Singularity Container Services library, Singularity would retrieve the public key from the key store automatically, as opposed to using the local as shown here. Now, we're going to push our newly signed container up to the library using the Singularity push command and adding a new tag name. Great! Our container has now been signed, verified, and pushed to the Singularity Container Services library. We should be able to see all of this if we look at the repository. If you want to change, add, or remove a tag, you'll need to use the web interface. Singularity Container Services repositories are private by default, so to share containers with other users, the repository will need to be made public. We'll jump into a new unconfigured WSL2 environment to mimic what another user might experience if they try to pull a container that is not public. After using a pull command, you'll see that the container is not accessible. To change this, go back to the web interface and make that project public. If you tried pulling a container from the library that is not public, you'll receive an error message that looks like this. And this once again brings us to the end of another installment in our series. We have taken what we've done in the past and signed our TensorFlow container, verified that container was unchanged, and then pushed that signed container to the Singularity Container Services library. In the next video, we will view and search for containers through the Singularity Container Services interface, as well as learn about some advanced Singularity functions. Don't forget to like this video and subscribe to our channel for more content like this, and feel free to leave a comment below if you have any questions on what we've covered, or if you have some ideas about what you'd like to see us cover in the future. Thanks, and see you next time.